Hello guys, let us now see few questions based on recurrence relations. Our first question says find first 6 terms of the sequence defined by an equal to an minus 1 plus thrice an minus 2 with the initial conditions a naught equal to 1 and a1 equal to 2. Basically, what you observe is the next nth term depends on the previous two terms. Nth term is written as the sum of n minus 1th term, the previous term, plus thrice n minus 2th term, that is bit back, next term. So, how to solve such questions? Every next term depends on the previous. What we are given here is a naught is 1, a1 is 2, and we have rewritten the recurrence relation. What you observe, if you put n equal to 2, this is a2 equal to a1 plus thrice a naught. You put the values of a1 and a naught. So it will be 2 plus thrice 1 giving 5. Then go to a3. You put n equal to 3, it becomes a3 is equal to a2 plus thrice a1, which is 5 plus thrice 2 giving 11. Fourth term you can see is a4 equal to a3 plus thrice a2. Put the values, the answer is 26. And similarly, you put n equal to 5, it becomes a5 equal to a4 plus thrice a3 equal to 26 plus thrice 11 equal to 59. So in this way we have got our first 6 terms. The very first term was a naught given to us, a1 was given to us, and with the help of a naught and a1 we have constructed next 4 terms. In all we are having our 6 terms with us. If it is given that other than a naught and a1 you find the next 6 terms, then you need to go ahead with a6 and a7 using the same rule. I hope we can achieve it. Now let us move to next question. This question asks us to solve the difference equation ar equal to 7 ar minus 1 minus 10 ar minus 2 with initial conditions a naught equal to 4 and a1 equal to 17. What we observe is our rth term depends on previous two terms. It is 7 times the previous minus 10 times the next previous term. So let us go. We have rewritten the equation. The characteristic equation we can write as, we will denote this, see this is just one step ahead and one step ahead. So I can write this AR as what? Square of our variable k square equal to, this is 7k minus 10. I would like to reiterate the same. We are going 2 steps ahead of this. If I treat this as 1, this is k and this becomes multiplied by k, so k square. So we have written the equation as what? K square equal to 7k minus 10. You rewrite it. This is your usual quadratic equation. What we observe is k square minus 7k plus 10 equal to 0. Constant term is plus 10. So the product of the factors we want to be plus 10. And sum of the factors should be minus 7. So we have done rough work over here. We know plus 10 can be got by having either both the factors to be positive or both the factors to be negative, because we know positive into positive produces positive result, negative into negative is again positive. So either both the factors will be negative or both the factors will be positive. So 10 we can split as 5 twos are or 10 ones are. These are the only two possibilities. We have selected -5 and -2. So -5 into -2 gives you +10. So this is k square minus 5k minus 2k plus 10. You can see -7k we have split as this sum. Now from the first two terms you can take k common, inside you are left with k minus 5. From the next two terms you are taking -2 common, inside you are left with k minus 5. So this is k minus 5, not 2. Yes, it is 5. Then k minus 5, the bracket is taken common, inside you are left with k minus 2. So this is the product equal to 0. When product is 0, if either of them is 0, so either k will be +2 or +5. So these are the characteristic roots. K equal to 2 and 5 are the characteristic roots. Then how do we write our solution? The general solution, we write some constant times our characteristic root raised to r plus some constant times another characteristic root raised to r. So what we have got? AR is equal to capital A times 2 raised to r plus capital B times 5 raised to r, where capital A and capital B are arbitrary constants. They are some constants. For any values of A and B, this relation proves to be solution of the given recurrence relation. Now they have given us some initial conditions. So to know the values of A and B, particular values of A and B, what we'll do is we'll use the initial condition. What initial condition is given to us? A naught is 4. Means for r equal to 0, the value of that term becomes 4. So A naught equal to 4 equal to, so we are putting r equal to 0 here. So this equation you can see A times 2 raised to 0 plus B times 5 raised to 0. This is what we have written. Anything raised to 0, of course the base should not be 0. So 2 raised to 0 is 1, we know. So this will be A only. 5 raised to 0 is 1, so this is B again. So what we are getting is A plus B is equal to 4. So in the rough, I have just noted the equation as A plus B equal to 4. Now, the second initial condition provided to us was A1 equal to 17, meaning R equal to 1. The first, R equal to 1th term will be 17. So this is what we have written, will be A into 2 raised to 1 plus B into 5 raised to 1. So what is it? 17 is equal to twice A plus 5B. So we have carried that equation here. Twice A plus 5B is equal to 17. And let us solve these two equations simultaneously. So what we'll do is we'll double this equation so as to get twice A. We got 2A, 2B equal to 8. And from that let us subtract this second equation. So what do we get? These 2A's get cancelled. 2b minus 5b produces minus 3b, and here it is 8 minus 17 giving us minus 9. So minus 3b is minus 9. So what will be b? 3. We divided by minus 3 to both the sides. We got b equal to plus 3. So this is what we are getting, b is equal to plus 3. Next, if I put b is equal to plus 3 in our equation, so what do we observe? A plus 3 is 4, meaning A is 1. So we got A equal to 1. This is the solution. So putting the values of A and B, we will get our solution back. AR will be A times, means 1 times 2 raised to R. So it is 2 raised to R. Plus B times 5 raised to R. So it is thrice 5 raised to R. So you can see this is the particular solution of the given recurrence relation. AR is equal to 2 raised to R plus thrice 5 raised to R. Let us move with one more example of the same kind, where we are having three initial conditions. Solve the recurrence relation AR minus 7 AR minus 2 plus 6 AR minus 3 equal to 0. You can see very directly. If I call this as first term, this will be second term, then the third term is hidden, and this is our fourth term. So if I call this as 1, there is next term, and one more term is hidden, and then we go here, means 3 times we have to travel. So this will be a cube minus 7a plus 6 equal to 0. Let me repeat. If I call this as 1 step ahead, and the next term, or you can show it somewhat like this. Let us once again try to. So you can see this is AR minus 3. Here it is AR minus 2. Here it is AR minus 1, and then you have AR. So from AR minus 3 you have to go once, then twice, and here then twice. This is what we mean to say. And that is why we are putting a cube. Middle term, is hidden. AR minus 1 is hidden here. Then you go to AR minus 2, so that is single A raised to 1, one step. And here it is plus 6 into 1 equal to 0. Now to solve this kind of thing, this is a cubic equation, not quadratic. So we can't use the formula for quadratic. So better let us go with synthetic division. What we have done is we have written the coefficient form. You see, the coefficient of a cube is 1 we have written. The term a square is missing here. So the coefficient is 0. Then minus 7, and then constant term 6. You can observe the sum of all the coefficients is 0. 1 minus 7 plus 6. Sum is 0, means 1 is the root. So let us divide by 1. Okay, we are now ready for synthetic division. What we do is, our first coefficient we just take it down. 1 taken down as it is. Now by this one we multiply to this one. 1 ones are 1. Now whatever we have got, we add them. Sum is 1. Again by 1 we multiply to this. 1 ones are 1 we have written here. Add these two, you get minus 6. Again minus 6 into 1 is minus 6 here. You add this is 0. Once you get a 0 here, which is the place for remainder, if the remainder is 0, then only the division takes place, as you know. So the division is complete. What this means is, this 1 indicates that the factor is a minus 1. And what is the quotient we are getting? It is a square plus a minus 6. So factorization, you can see this is a minus 1 as our first factor multiplied by a square plus a minus 6 equal to 0. Now to factorize this a square plus a minus 6, you can see you want product to be minus 6 and sum to be plus 1. If the product is negative, it's natural that the factors have opposite signs. If one factor is positive, the other has to be negative. So here we have tried with the rough work. Minus 6. What are the factors of minus 6? You can achieve 6 by 3 twos or 6 ones. This is the only thing. For 3 twos, you want minus 6. So the factors will be either minus 3 and 2 or 3 and minus 2. The other fact says minus 6 can be factorized as minus 6 into 1 or 6 into minus 1. In each case, what is the algebraic sum of the factors? Minus 3 plus 2 produces minus 1, whereas we are having plus 1 here. 3 minus 2 produces plus 1, which we want. If I go with minus 6 and 1, the sum will be minus 5, which is not there, so that is wrong. And 6 minus 1 produces 5, which is not there. So what is the correct one? Perhaps the correct one is, we can see, the correct one is this one, 3 minus 2. So we have factorized this way. A minus 1 already we have got. Just now we got a plus 3 into a minus 2. And the product is 0. When product is 0, if either of them is a 0, 1. So value of a will be either plus 1 or plus 2 or minus 3. So the general solution can be written as what? Some constant times 1 raised to r plus constant times 2 raised to r plus constant times minus 3 raised to r. This is the solution. What are a, b and c? They are arbitrary constants. Now to find the values of a, b and c, we have to use the given initial condition. The given initial condition is a0 is 8, a1 is 6 and a2 is 22. So for putting n equal to 0, I mean r equal to 0, we'll get a0 equal to 8 equal to a into 1 raised to 0 plus b into 2 raised to 0 plus c into minus 3 raised to 0. Meaning thereby we got a plus b plus c equal to 8. This is our equation 1. Let us use the second condition, that is a1 equal to 6. It will be a in bracket 1 raised to 1 plus b in bracket 2 raised to 1 plus c in bracket minus 3 raised to 1. So what it produces? A plus 2b minus 3c equal to 6. This is our second equation. Let us go with third condition, that is a2 equal to 22. So here I have a into 1 square plus b into 2 square plus c into minus 3 square, meaning thereby a plus 4b and minus a square is again plus, so it is plus 9c equal to 22. Now to solve these three equations simultaneously, we have taken it separately. We have rewritten it as a plus b plus c equal to 8, our first equation, a plus 2b minus 3c equal to 6 as our second equation, a plus 4b plus 9c equal to 22 as our third equation. Now what we'll do is, from second equation let us subtract the first one. So if I do so, it will be a minus a cancelled. 2b minus b gives me single b, and minus 3c minus c will produce minus 4c. Right side will be 6 minus 8, so minus 2. So it is so simple. What we got is b minus 4c is equal to minus 2. Now let us go to the next. You can see this is a plus 4b plus 9c equal to 22, and this is a plus 2b minus 3c equal to 6. So let us subtract 2 from 3. So a minus a 0. 4b minus 2b produces 2b, you can see here. 9c minus 3c, I'm sorry, 9c minus 3c. So it becomes 12c, and 22 minus 6 produces 16. Now all of them, they are even, so I can divide them by 2. So I get 1b plus 6c equal to 8. Now from these two equations, let us try to eliminate b. So the latter equation we have written first, b plus 6c equal to 8. From that we are subtracting the upper equation, my b minus 4c equal to minus 2. Subtraction changes all the signs, so this is minus, this is plus, and this is plus. What we observe is the sum is 10c, here it is 10, so very directly c is plus 1. If c happens to be plus 1, This will be B minus 4 equal to minus 2. So B is equal to 4 minus 2 is 2. And if I put the values of C and B over here, what I find is A plus 2 plus 1 is equal to 8. Means A plus 3 is 8. So A is 5. So we got the values of A, B and C. By putting A, B and C back, we get the solution AR equal to 5 times 1 raised to R plus twice 2 raised to R plus 1 times minus 3 raised to R. These are particular solution of the given recurrence relation. Let us move ahead with next question. This is a tricky question, you can see. Consider the recurrence relation an equal to an minus 1 plus twice an minus 2 with a9 equal to 3 and a10 is equal to 5. You can see this is not initial condition they have given, no doubt, but they are not starting with a0 and a1. They are mentioning 9th term and 10th term directly. And they are asking you to find out a7 and a12. You can see a7 is before a9 and a12 is after the condition. So let us see how to solve such questions. We rewrite the given equation. As you know, these are first term, second term and this third term. So very directly I can write this as what? Sum m square is equal to m plus 2. You can see somewhere we have used k, somewhere we have used t, somewhere we are using m. So this is just a notation. We just want to give what is the characteristic of this equation. This we can call it as auxiliary one. Okay. Now rewriting this, what do we get? M square minus m minus 2 equal to 0. So this becomes, product you want minus 2 and sum you want minus 1. Again on the same conditions. Product is negative means the factors will have opposite sign and the sum is minus. So you can see this has to be minus 2 and plus 1. There is no alternative. So we got the factorization to be m minus 2 into m plus 1 equal to 0. And obviously m equal to either minus 1 or 2. So these are the characteristic roots. Therefore the general solution will be written as AR is equal to capital A times minus 1 raised to R plus capital B times 2 raised to R, where A and B are arbitrary constants. Now let us use the conditions. The word initial doesn't suit over here. So what we'll do is, with the help of given conditions, let us say, with the help of given conditions, we'll find out A and B. Now A9, they have supported us with A9. A9 is 3. So it will be obviously A into minus 1 raised to 9 plus B into 2 raised to 9. Negative raised to odd is negative. So it is minus A plus 2 raised to 9 is 512 into B equal to 3. As far as the powers of 2 are concerned, one must know powers up to 10th. 10th power of 2 is 1024. We must be very aware of the powers of 2 up to 12 and powers of 3 at least up to 6. Okay. Now A10 is supplied to us. A10 is 5. So this will be A into minus 1 raised to 10 plus B into 2 raised to 10. And as I have stated, this is minus 1 raised to even number, so it is plus. And 2 raised to 10 is 1024 times this B. And the sum they have given us 5. Now to solve these two, it is direct, you can see, you can add them. So in rough we have done so. We have added the equations, so we get 1536, B is equal to 8. So B will be 8 upon 1536, you divide it and we'll get it to be 1 upon 192. Now to get the value of A, we have to put this in either of them, so we put here because a is having minus sign. Let us drive this a to that side and 3 to this side. So 512 into the value of b minus 3 is equal to a. Now you divide this by I think 16. 16 threes are and 48. So remainder is 3, 32. So 16 twos are. And here it is 16 ones are. 3 is left, 16 twos are. Okay. Then again you find this 32 and 12. They are divisible by 4. So 4 8s are and 4 3s are. So you got this to be 8 by 3 minus 3. So what you will get? 8 by 3 minus 3 meaning 8 minus 9 by 3. So it is minus 1/3. So the answer is minus 1/3 here. So the solution is given by AR is equal to minus 1/3 the value of A into minus 1 raised to R plus 1 upon 192 into 2 raised to R. Now you are required to find out A7. So put R equal to 7 everywhere. So you'll get it to be minus 1/3 into minus 1 raised to 7 plus 1 upon 192 into 2 raised to 7. So this is odd power of minus, so it is minus into minus makes it plus 1/3. Plus it will be 2 raised to 7 means 128 upon 192. Carry out the division. You'll get it to be 1/3 plus 2/3, meaning 3 by 3 is 1. So A7 is 1. And the next you see, you are required to find out A12. Again you put R equal to 12. So it is A12 equal to minus 1/3 into minus 1 raised to 12 plus 1 upon 192 into 2 raised to 12. Now this is even power of negative. So it is plus. And plus into minus keeps it minus. Then it is 1 upon 192, okay. 2 raised to 10 we know 1024 and multiplied by 2 square, so that is 4. Laws of indices. You may do on your way. You can have 2 into 2 into 2 12 times, or anyway. You can have this as 2 square raised to 6 also and solve it. Ultimately, where you reach to, the division becomes 64 by 3, and from this minus 1/3 you can add. So it gives you 63 by 3, meaning 21. So value of A12 becomes 21. So hope you enjoyed the recurrence relations. Thank you and bye.